All right, we're going to talk about what's called the greatest common factor. And what we talked about in the last lesson is we found the product of primes or prime factorization of numbers. And that kind of leads into what we call greatest common factor. Now, you've done greatest common factors before. So, for example, if we had 10 and say you had 12, and you had to list the factors of 10, which would be 1 and 10, 2 and 5. And if you listed the factors of 12, which would be 1 and 12, 2 times 6, and 3 and 4, well, you found that the greatest common factor, what's common? What's a common factor between these two numbers? You would see that I have a 2 that's common in both. Now, you also have a 1, but the 2 is the greatest common factor. So the greatest common factor of 10 and 12 is 2. And that's probably how you maybe best remember this. Now, the problem with this method is if you get to really large numbers. So for example, say I asked you to find the greatest common factor of 428 and 950. Now, you really don't want to list all the factors of 428 and list the factors of 950. That would take a long time. So that's where finding the product of primes is useful. And what I want to do here is just review prime factorization, or in other words, product of primes. So I'm going to write down two numbers, and I'm going to try to erase this as quickly as I can. Might not get it all, but that's okay. So I'm going to take, say that we had 28, and say that we had 30. And I want to find the greatest common factor. Now, you might right away say, all right, I know what that is. I know what the greatest common factor is, because you may know your factors pretty well with numbers that aren't too big. But again, get used to using factor trees, or in other words, product of primes to do this. So I'm going to do a factor tree. Let's see, 28, I could use 4 times 7. I can break down the 4 to 2 and 2. So I have a 2 squared times 7, right? Now for 30, I could use 5 times 6, or you could use 3 times 10, and then break down the 6 to 2 and 3. And here my product of primes is 2 times 3 times 5. Now I'm going to find the greatest common factor. And again, it's got to be what's in both of them. What's common in both of them? For example, do you have a 3 in both of them? No, I don't. Do you have a 5 in both of them? You do not. Do you have a 7 in both of them? You do not. But you do have a 2 in both of them, right? Now over here, you have 2 2's, right? 2 times 2. Over here, you just have 1 2. Do you have 2 2's common in both? So in other words, over here, do you have 2 times 2? And over here, do you have 2 times 2? The answer is no. You have one factor of 2 here and 2 factors of 2 here. You have 1 2 that's common. You don't have 2 2's that are common. So the greatest common factor is simply 2. Let me example. All right, let's take 100, and let's take I'll say 125. And I'm going to quickly go through a product of primes. So 10 times 10, break those down to 2 and 5. Break that down to 2 and 5. So what do I have there? I have a 2 squared times 5 squared. Now for 125, let's see, I know I've got some, on $1.25, I have quarters in there. So I have, 5 of them? So 5 times 125, and break that down to 5 times 5. So in other words, I have 5 cubed there. All right, so here's my product of primes here. Here's my product of primes here. Now I'm going to find the greatest common factor. What's common in both these? Do you have 5's in both of them? Answer is yes. Do you have 2's in both of them? Answer is no. So no, you don't have 2's in both of them. But I do have 5's in both of them. How many are common? How many do you have in common in both of them? Now here you have 2 5's. Here you have 3 5's. Do you have 3 5's common in both of them? Answer is no. But you do have 2 5's, because here I have 5 times 5, right? Here I have 5 times 5 times 5. I have two 5s common in both of them. So my greatest common factor is 5 squared, or in other words, 25. 25 is the greatest common factor of 100 and 125. And that makes sense, right? Because 25 is a factor of both those numbers. All right, let's take a look at example 1. And let's really get into this now. It says find the greatest common factor. Now, what I have here is I have 3 terms. And we want to find the greatest common factor of these 3 terms. So the first thing I'm going to do is I'm going to do my factor trees for 6. It's 2 times 3. So I have a 2 times 3. I'm going to do my product of primes for 14, 2 times 7. So 2 times 7. And for 24, let's see, I could use 4 times 6. Break that down to 2 and 2. Break the 6 down to 2 and 3. So what do I have there? 2 cubed times 3. Now let's just take a look at the number part of this. Then we'll get to the letters. Alright, so for my greatest common factor, what's common in all 3? Do you have a 2 in all of them? Answer is yes. How many are common? Let's see, 1, 2 here, 1, 2 here, 3 here. What's common? How many are in each of those? I have a 2. I have one factor 2 in each of them. Do you have 2 2s in each of them? Answer is no. Do you have 3 2s in each of them? Answer is no. But you do have a 2 in each of them. So my common factor for the number is 2. Now, how about 3s? Do you have 3s in all of them? I got a 3 there. Nope, I don't have a 3 there. So I don't have a common factor of 3, nor do you have a common factor of 7. So for number-wise, you got a 2 in all of them. Now let's look at the letters. 2 x's here, 1 x there, 10 x's there. How many are common? Do you have 2 x's in each of them? Answer is no. Do you have 10 x's in each of them? Answer is no. But do you have an x in each of them? Do you have at least an x in all of them? So I'm kind of emphasizing that. Answer is yes. I do have an x, at least one x in all of them. I have at least one x in all of them. I can't say that I have 2 x's in all of them or bigger than that. So I have a common factor of x. How many y's are common? Let's see, 3 here, 5 here, 6 there. How many are common? Now here's a little trick of the trade. If you're struggling with how I'm explaining this and how many are common, all you got to do is choose the lowest exponent. So here I have a 3, here I have a 5, here I have a 6. Well, what's common? It would be y cubed, the lowest exponent. Now how many m's are common? Well, you have 1 there, 2 there, 4 there. Pick the lowest exponent, which would be m to the first, or m. This is my greatest common factor. Now go back and see if this makes sense. Does it seem like I have a factor of 2 in all these? Yep. Does it seem like do I have an x in all of them? Yep. Do I have a y? Do I have at least 3 y's in all of them? Yep. And do I have an m in all of them? At least an m in all of them? Yes, I do. Example 2 now. All right, same thing. I'm going to start by doing a factor tree. So 5 I can't break down. So 5 is my prime factorization. Now here I could use 6 times 10, 2 times 3, 2 times 5. So what do I have there? 2 squared times 3 times 5. For 30, 5 times 6. Break down the 6 to 2 times 3. So what do I have? 2 times 3 times 5. Alright, let's find the greatest common factor. Let's do the numbers first. What's common for the numbers? Let's say I have a 5. Change colors here. I have a 5. I have a 5. And I have a 5. So 5's common. I don't have to worry about choosing the lower exponent because there's just one 5 in all of them. Now, do you have any other numbers common in all 3 of them? Do you have 2's in all of them? Answer's no. Do you have 3's in all of them? Answer's no. Okay, let's do the letters now. So I have so many A's, so many B's, and so many C's that are common. How many A's are common in all 3 of these? Choose the lower exponent, 2. right? You have at least two A's in all of them. You don't have more than two A's common in all of them, do we? Okay, how about B's? Take the lower exponent. I have a 2, I have a 3, I have a 4, lower exponent. How about C's? 2, 3, 4, choose the lower exponent. The greatest common factor is that. Okay, let's take a look at example 3. And I'm going to go through this one a little faster. So let's see, 12, I could go 2 times 6, which is 2 times 3. 4 times 4, which breaks down to 2 and 2 for each of them, which would be 2 to the 4th. This would be 2 squared times 3, right? And finally for 28, 4 times 7, 2 and 2, so 2 squared times 7, right? All right, let's find the greatest common factor. What's common for numbers in all of them? I have 2's in all of them. Choose the lower exponent, 2 squared, or 4. You definitely got to write that as 4, not 2 squared. All right, what's common? Is there any other numbers common in all of them? Do I have 7's in all of them? No. 3's in all of them? No. Now, how many x's, how many y's, and how many p's? For x's, I have 1. Lowest exponent is 1. For y's, let's see, 5, 2, 1. Lowest exponent, 1. How about p's? 1, 16, 5, lower exponent, 1. Greatest common factor is 4xyp. So, this is what we call finding the greatest common factor.